Colocation analysis enables us to identify individuals who are at the same place at the same time. For this example, we'll identify colocations in a dataset about individuals in New York City. First, we need to load the dataset for analysis. For this example, we'll use one of the samples installed with SAP Predictive Analytics. Next, we'll load a data description that identifies the characteristics of the variables. Now we can see information about the dataset, which includes a user column, a location column, latitude and longitude columns for each location, and a check-in time column to timestamp the user's arrival at each location. The isTourist and isMustSee variables identify users as tourists or locals and flag certain locations as common destinations. Before we can proceed to the next screen, we're prompted to create a composite variable that combines the latitude and longitude columns into a single position-based variable. Here the geolocated item, position, and date column variables have been identified automatically. The tile size in meters setting specifies the size of the area around each location that we want to consider. The larger the area, the more events are considered to occur in the same location. For this example, we'll reduce the size to 20 meters. In the time period area, we can specify a start and end date and time for analysis if desired. In the miscellaneous area, we can specify the maximum number of connections for each location. Connections beyond the maximum will not be considered when training the model. For this example, we'll use the default settings. In the colocation interval area, we can specify the maximum time interval between two events that will be considered to occur at the same time. For this example, we'll use the default setting of 1 hour, meaning that two individuals who arrive at the same location within an hour of each other will be considered to be colocated. Optionally, we can set a limit on the maximum number of colocations to analyze. Before creating a model, we can specify if we want to enable community detection and optimize megahub detection. Communities are subgroups within a dataset with more internal connections than connections with the rest of the network. Megahubs are individual nodes with a large number of connections, such as call centers. Detecting communities and megahubs can increase model quality, so we'll detect both. Here we can see a summary of our modeling parameters. Now we'll generate the model. Here we see an overview of the modeling results. Note the nodes are listed in two separate repositories. One repository is for users, the other is for locations. First, we'll look at the nodes display. In the graph area, we can choose between proximity graph, which allows us to explore links between users and locations, or user, which allows us to view colocation relationships between users. First, we'll select a user and view the locations they visited. The weight beside each user indicates the number of locations they visited. We'll select the user who visited the most locations. Here we can see all of the user's visited locations. Next, we'll select location, referred to here as a tile, and visualize the users who visited it. Here the weight refers to the number of users who visited the location. We'll select the tile that was visited most. Now we can see all of the users who visited the selected location. Now we'll switch the graph to user mode to see who is at some point co-located with a selected user. Now we can see the other users who've been co-located with the selected user. The line thickness indicates the number of colocation instances. Now we'll look at the colocations for this user in more detail. Here we can choose to look at colocations by user or by location. We'll start by looking at colocations by user. Now we can see all of the colocations for the user. The item columns display the user numbers of the colocated individuals, and the date columns indicate the time at which each individual arrived at the location. Next, we'll group by tile to see the list of colocation tiles for the user. We can see the two locations where the colocations for this user occurred. Now we'll look at all of the colocations from the whole dataset that occurred at one of these locations. Now we can see all of the colocations that occurred at this tile. You now know how to use colocation analysis in SAP Predictive Analytics. For more SAP Business Intelligence tutorials, visit sap.com/learnbi.